Imagine wildfires raging across the continent, tsunamis crashing against coastlines, and almost 75% of species on our planet going extinct. That's what happened when the most devastating asteroid we know about hit our planet. Yes, I'm talking about the one that wiped dinos off the face of the Earth. But I've got some shocking news in store. This asteroid might have had a companion. Scientists discovered something that might be an impact crater 250 miles off the coast of West Africa. They were looking at the data from the seismic waves that the researchers had sent underground. Their goal was to check the ocean floor's terrain by observing the waves ripple through Earth. That's when they spotted a large bowl-shaped structure with a broken-up floor and a central peak. These features are very common for an impact crater. But the most unexpected thing was that the timing of this potential asteroid strike, which seemed to occur around 60 million years ago, could make it a sibling of the dinosaur-ending Chicxulub asteroid. This second asteroid might have broken off the main one, or they could have been part of a closely timed impact crater. You, along with many other people, might have questioned yourself, how come just one asteroid could have caused so much destruction that we don't see dinosaurs roaming the planet anymore? Well, that second asteroid might have helped. Researchers dubbed the crater it supposedly left the Nadir crater. The name comes from the nearby underwater volcano. The discovery itself happened in 2020. It hasn't been confirmed yet that the crater was caused by an asteroid. But its features, including its scale, the height of the crater rim, and the ratio of height to width, most likely mean an impact origin. Plus, the deposits surrounding the Nadir crater look like something ejected from a crater after a collision. Scientists created some computer models and figured out that to cause such an impact, an asteroid had to be around a quarter of a mile across. Even though the Chicxulub itself was way larger, around 6 miles in diameter, the second hit would have been pretty impressive as well. The energy released at the moment of the collisions would have been more than 1,000 times greater than the eruption and tsunami in Tonga in January 2022. The hit would have also produced shockwaves equivalent to a magnitude 6.5 to 7 earthquake. It would have triggered underwater landslides, as well as a series of tsunamis. In any case, discoveries of such terrestrial impact craters are always a big deal. They're quite rare. Researchers have found fewer than 200 confirmed impact craters on Earth. Almost all of them have been discovered on land. There are also several likely candidates, but their origin hasn't been confirmed yet. What can the newly found crater be if it wasn't left by an asteroid? It could be a collapsed volcanic caldera, or it could be a salt diapir, which is a squeezed body of salt. To confirm that the Nadir crater was created by an asteroid strike, scientists need to drill into the formation and gather samples. The evidence scientists are looking for might be shocked quartz, a mineral that appears when asteroids crash into our planet. If we do find it, we'll hopefully learn whether this discovery has any connection to the Chicxulub. Its fall led to terrifying consequences on Earth. The asteroid is believed to have come from the outer reaches of the solar system. When it crashed into the planet, the force of the collision was so powerful that the space rock didn't stop until it got through Earth's crust to a depth of several miles. The impact left a crater more than 100 miles across. Thousands of cubic miles of solid rock instantly turned into vapor. The crash set off a series of natural disasters that erased around 75% of plant and animal species on Earth. Animals that were close enough to see the crash didn't survive for longer than a few seconds. Close to the impact crater, the ground was covered with thousands of feet of hot ash, grit, and rubble. Several seconds after the collision, everything for many miles around burst into flames. What didn't burn down within the next several minutes faced a different, even more terrifying problem. The asteroid also produced a monstrous, largest ever tsunami. A recent study claims that it was thousands of times larger than any wave people have ever seen. You see, the splashdown was so powerful that it left its signature on the face of our planet. In 2021, researchers found out that the collision had carved mega ripples into the Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists even remodeled the events of the first 10 minutes after the impact, and the model showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. And of course, all that empty place didn't stay empty for long. The ocean gushed back to fill the crater, but in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. No wonder the largest and fastest moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall and moved at a speed 10 times greater than more distant tsunami waves. During the first hours after the crash, the sky was almost totally dark. Later, it started to get lighter, but very, very slowly. For the next couple of years, the world seemed to be stuck between a cloudy day and twilight. Lots of plants didn't survive this dimness and the absence of sunlight. The ash stayed in the air for months. That's why when it rained, the water became highly acidic. Fires kept raging. They produced tons of toxic gases that destroyed the ozone layer, at least for some time. The gases and particles that had been flung into the atmosphere blotted the sun out. This caused temperatures to plummet by over 60 degrees Fahrenheit. Lots of plant and animal species that managed to survive the impact itself couldn't stand these new hostile conditions. By the way, the infamous asteroid could have also been part of a shower, since there's some evidence that many other space rocks smashed into the moon at approximately the same time. In December 2020, some glass was found on the moon. It could have been forming there over billions of years as the soil was ejected during asteroid impacts. The discovered glass was delivered to Earth by the Chinese National Space Agency's Chang'e 5 lunar mission. Researchers have concluded that the super tiny glass beads were indeed created by the heat and pressure of meteorite impacts. It means that their age should be the same as the time of the collision. Using the glass beads, scientists managed to create the timeline of such collisions. They think the timings of asteroids hitting the moon could mirror the impacts of asteroids hitting our planet. Even more exciting, scientists have found out that the age of some lunar glass beads coincides with the age of some of the largest impact craters on Earth, including the Chicxulub impact crater. If this theory about smaller impacts accompanying large impact events on our planet turns out to be true, we'll get important information about asteroid impacts on Earth and the inner solar system. Now, researchers are planning to compare the data received from the Chang'e 5 samples with other samples of the lunar soil from different craters. It may reveal new evidence about what impacts may have influenced life on Earth. For more than 170 million years, they dominated our planet. From small creatures that were only a few feet long to some of the biggest animals to have ever roamed the land. Let's admit it, the age of dinosaurs gave us some pretty scary predators, like T-Rex, Spinosaurus, the Velociraptor, Gigantosaurus, and so many others that made the rest of the animals shiver in fear. But everyone talks about dinosaurs all the time, so it seems like no other scary beasts ruled the animal kingdom besides them. But check out these reptiles. They dominated the prehistoric world for more than 120 million years, way before dinosaurs. But even before them, nature had to create the first true reptile. There was a swampy, wet era when many new groups of plants grew into great forests in tropical deltas and swamps. Trees were not like those we see today. They were mostly horsetails, club mosses, and the first seed-bearing plants called gymnosperms. It was during this time that the first peat bogs formed too. The most common creatures on land were prehistoric amphibians, which evolved from fish that were basically sick of being in the water all the time. So they decided to take a walk to see what was happening on dry land. Those early amphibians had a problem though. They depended on water to stay well hydrated and lay their eggs, so they couldn't go too far from lakes, rivers, and oceans. At least not until a special creature called Hylonomus evolved. With its 4 legs and scaly skin, we're looking at our best candidate for the first true reptile. These features help the animal move away from the water and explore dry land. As plants were intensely growing back then, they produced more and more oxygen, which probably helped these complex animals, such as our buddy Hylonomus here, develop. Let's rewind the story a little bit. 300 million years ago, Earth was hotter and drier, which was not that good for amphibians, but was great news for small reptiles like Hylonomus. These reptiles were able to regulate their body temperature and lay eggs on land, so they didn't need to stay close to water. That's when they started evolving into different groups. One was called Pelicosaurs, and they lived in different ways. Some ate plants, while others preferred meat. You might recognize the most famous one from their group, with a big sail on its back. People often mistake this creature for a dinosaur. Over time, some pelicosaurs evolved into the so-called mammal-like reptiles we called therapsids. Therapsids had stronger jaws and sharper teeth, and some could stand upright on their legs, unlike their ancestors that moved more like lizards. Take Gorgonopsians, one of the top predators of their time that even dinosaurs wouldn't have liked to face. In a way, they were similar to mammals because they were probably endothermic, which means their body had a constant internal temperature. They had long legs good for running and hunting. They mostly lived in southern Africa, but their fossils were spread across Europe and China too. Oh, the joys of times when continents were joined together. Top predators had no limits back then. Gorgonopsians went after different animals, especially those armored ones related to turtles. That's the type of chase I wish I had the chance to see. Some Gorgonopsians had really big skulls, almost 1.6 feet long. Scientists think some of them may have hunted in groups, but we're not sure about that. One specific Gorgonopsian was about 3.2 feet long and had a skull that looked like a wolf's face. It had long, sharp teeth in both the lower and upper jaw, similar to the saber-toothed cats. You may have heard about these from the Ice Age. Such teeth were good protection in such messy, insecure times. And we need to mention the Permian extinction. About 250 million years ago, 90% of all species, including animals in the seas and on land, as well as most of the trees, disappeared from the face of the Earth. Why did this happen? Scientists are still not sure. One theory says it may have been a massive asteroid impact, while another theory claims the spread of toxic levels of carbon dioxide in the ocean erased marine life. There's also some evidence of massive volcanic eruptions around the same time as the extinction. These eruptions could have released gases into the atmosphere, causing acid rain and making our home planet cooler. And all these things might have affected life in the ocean and reduced diversity in animal and plant kingdoms in general. Whatever the reason for the worst mass extinction in the history of our planet was, the rhapsids managed to go through all these troubles and survive. Not only that, they spread out and evolved into many different groups. Some of them even got cool features that made them more similar to mammals. Fossils show some reptiles had fur and maybe even warm-blooded metabolisms. They may have had wet black noses, like dogs, but it would be tricky to take this one for a walk. One of them might have given birth to live young, which is a characteristic of mammals rather than reptiles. Unfortunately, therapsids eventually went extinct and ended up being replaced by archosaurs, which were finally the ancestors of dinosaurs. But not all of them disappeared. Some survived alongside dinosaurs for millions of years. That probably wasn't an easy task. They continued to evolve and eventually became the first prehistoric mammals. But moving back to the pre-dinosaur era. Wait, what's that buzzing sound? Oh wow, the biggest insect ever! Yup, it's Meganora, a giant dragonfly that lived about 300 million years ago. Its wingspan could be more than 28 inches. They were predators and would mostly go after other insects, but I'm not sure I'd feel safe if they were flying around these days. Imagine getting back from a camping trip and instead of scary stories about terrifying beasts wandering in the woods, you only have one where an insect pushed you down and stole your stuff. And it's really weird these insects could grow so big during the period when they lived. One idea says it's due to higher oxygen levels in the air at that time. A lot of carbon ended up trapped in plants, so the oxygen levels were higher. Insects breathe in a different way than most animals. They have these special tubes called trachea that deliver oxygen directly to their body tissues. But this system is not very efficient for bigger insects. Oxygen moves slowly through the trachea, so the tissues in the middle of big insects wouldn't get enough oxygen to survive in today's world, where there is less oxygen. And for that, I'm very, very happy. And what about Arthropleura, a giant millipede that lived more than 300 million years ago? It was one of the biggest invertebrates ever discovered that could grow up to 8.5 feet, similar to a small car. Now that's a ride I wouldn't like to take. And once again, lots of oxygen probably gave a chance to these creatures to grow up to be the biggest of their kind. Arthropleura weighed around 110 pounds, which would be similar to a big dog. And it used to roam the beaches of ancient England. Well, okay, I'm fine. I'll find a pool somewhere. And their fossils showed us where they lived. Many used to think they preferred coal swamps, but newer research tells us they mostly lived in open woodlands. They could get a lot of food there, like seeds, nuts, and of course, some other small innocent animals. These creatures existed for about 45 million years and went extinct more than 250 million years ago. No one knows for sure why they disappeared, but some scientists believe they may have been competing with reptiles that eventually replaced them. And this slowly led to the rise of our beloved dinosaurs. So we're moving to 66 million years ago in the world where dinosaurs lived. What are we doing here? We're just watching these giant reptiles and waiting for one of the most massive disasters on our planet to strike. Right now, a giant asteroid bigger than Mount Everest is flying at a tremendous speed, exceeding the speed of sound 40 times in the direction of our planet from the depths of space. It passes through our atmosphere, heats up, and hits the coastal part of the island of Yucatan, which separates the Gulf of Mexico from the Caribbean Sea. The enormous release of energy destroys all living things in the area, on land and in the ocean. The air over the island is filled with smoke and ash. Yucatan Island has taken the brunt of the blow. The blast wave instantly turns the green territory into a giant, lifeless crater. The asteroid fell at the wrong time. By the moment of the catastrophe, Earth had already been undergoing devastating changes. Continents were separating from one another, and some volcanoes were waking up, pouring lava onto the ground. Dinosaurs had been almost on the edge of extinction, but the asteroid shaped their fate. Now, Yucatan looks like a giant funnel of melting rock. There are no more dinosaurs here. But what about those animals that were far from the crash site? The noise from the explosion was so loud that pterodactyls hanging out far from the crater flew up into the sky in fear. A Tyrannosaurus got distracted from its hunting and ran away as far as possible, along with Triceratops. But somewhere, even further, in mainland Mexico, ancient lizards continued to chew grass and run around fields. They did notice a bright flash, but didn't mind it. They didn't even hear the sound of the explosion because the sound wave dissipated in the air. No blast wave, no earthquake, and no meteor shower. Dinosaurs continue with their lives. Unfortunately, not for long. Most dinosaurs would have survived if the meteorite had fallen in a field, ocean, or any other place. Perhaps today we would see them in nature reserves, but the meteorite fell in the most unfavorable place. According to studies, the giant rock had a 1 in 10 chance to destroy dinosaurs, and it took this chance. It wasn't a soft landing. The stone didn't slip on the ground, but hit the rocky terrain like a giant hammer. The catastrophe wasn't limited to a blast wave and a crater. The asteroid fell into large stalks of flammable materials. Simply put, the space rock got into a giant vat of combustible substances. This provoked a drop of millions of tons of soot and ash into the air. The fire quickly spread throughout the island, emitting black smoke into the sky. Dinosaurs living hundreds of miles away from the site are getting nervous. Feelings of anxiety are growing. Their inner instinct of self-preservation signals that disaster is coming. The sky becomes gray and darkens. Black clouds cover the sun and reflect the light. However, these are not just regular clouds, but volcanic ash. The asteroid fell at the most destructive angle. It also hit the coastal part, so the destruction reached the seabed filled with sulfuric acid. And now it's all coming out. Toxic fumes get mixed with incandescent ash, soot, and metals the meteorite contained. A fiery hot cloud emits acidic smoke that is very harmful to health. And this cloud, driven by the winds, grows and stretches all over the continent. It's getting cold on the ground. Plants, grass, and trees are quickly withering. The green valley, saturated with life, becomes gray and lifeless, which leads to an imbalance in nature. Most dinosaurs can't get fresh grass and leaves. This problem also affects predatory reptiles since the number of herbivorous lizards significantly decreases. Animals start to freeze and starve. They move away to search for some food and find a warm place, but it's too late because a poisonous firestorm is approaching them quickly. Dinosaurs try to hide in burrows and caves. Some lizards are looking at the sky, which is getting darker each second. A tiny sparkle slowly falls from a black, fiery cloud. This is a particle of hot ash. It drops to the ground, touches the dry leaves, and sets them on fire. Millions of such particles fall to the ground. The forest flares up like a match. The smoke from the burning trees rises and becomes part of the expanding ash cloud. The more the fire spreads, the larger the ash cloud becomes. Sulfuric acid vapors mix with molten metal particles and fall to the ground as poisonous droplets. Acid rain corrodes vegetation and poisons the soil. Flying lizards rise into the sky and enter the center of the firestorm. Dinosaurs on the ground are running from the forest towards the water, but it's impossible to escape from the apocalypse. The scale of the disaster is increasing exponentially. While acid rain and firestorms destroy one part of the continent, the coastal side faces another problem. The fall of the meteorite caused a giant tsunami. It hits the shore and floods large areas of land. After the massive explosion, the first wave forms. It could quickly destroy modern-day New York. A series of smaller waves, the size of a 5-story building, sweep across the Atlantic Ocean and the North Pacific Ocean. Giant tsunamis are not so scary for deep-sea dinosaurs, but the poisonous cloud poses a danger to them. Particles of sulfur and ash cover the sky above the water surface and bring down poisonous rain. Seaweed and phytoplankton don't survive it. Thus, millions of fish face the threat of famine. This causes huge problems for the whole food chain in the ocean. Giant sea lizards can't survive either. The meteorite created a domino effect that put the entire continent under threat of extinction. A few weeks have passed. The ashes have settled and cooled down. The fires are over, and the air has become cleaner. The sun is finally peeking through the clouds. But the planet looks different now. Giant lizards don't exist on the planet anymore. Green forests have turned into gray fields. Fortunately, not for long. The seeds of plants and trees have survived the apocalypse and are now blooming with renewed vigor. Nature is filled with colors again. Little creatures similar to rats have been hiding in the ground and have also survived. And now they finally get out to continue spreading life. It wasn't firestorms, tsunamis, fires, and lack of sunlight that destroyed the dinosaurs. The primary damage to the world at that moment was the disruption of the food chain. All big herbivorous dinosaurs and giant toothy monsters lost their food sources. Small animals and some flying dinosaurs survived to further evolve into modern birds and mammals. Large animals, the size of a rhinoceros, appeared 15 million years after the disaster. Tens of millions of years passed since that moment, and then humanity appeared. Thanks to modern technology, we've discovered the reasons for the destruction of dinosaurs. We don't know every detail, but we have a common picture of those events. And the scariest thing is that if the same asteroid fell again into some explosive terrain, we wouldn't be able to do anything about it, and our remarkable technologies wouldn't help much. Yes, we might disperse ash clouds and extinguish some fires, but it would be insignificant. Floods, fires, and acid rain would make life in big cities unbearable. The only thing that would help us survive could be underground bunkers and other reliable shelters. But how to survive the famine that would come after the destruction of vegetation and crops? We are developing and improving technologies that can protect us from asteroids, like lasers or space rockets with explosives. But even if we destroy one big rock, it might tear into a million pieces. Some will burn up in the atmosphere, and some will fall on the planet in the form of a meteor shower. Anyway, we'll face huge natural disasters. Therefore, all we can do now is hope that no rock from space will come to us.